Hello, I'd like to welcome you to our little unit on chemistry. I'm going to talk you through the PowerPoint presentation on chemistry and hopefully lay a foundation for our understanding of biology. One of the most important ideas in this whole chapter is that biology really has as its foundation chemistry, the way that the various substances in a biological organism are composed and the way they function in chemical reactions. So the learning objectives that we'll be reviewing are outlined on this first slide. And I'm not going to run through this list now, but we'll step through each of these learning objectives and hopefully start to understand how chemistry relates to biology and how chemistry works. So the first learning objective is the fact that chemistry is the basis of understanding biology, and specifically the part of biology that is how a biological system stays alive, how it keeps going, the idea of metabolism. So a lot of people that are interested in biology don't think they have much interest in chemistry, but chemistry turns out to be very relevant to biology. The reason is what chemistry actually is. Chemistry can be defined as the study of chemicals and their reactions. And that makes you ask the question, what are chemicals? And this word kind of has a negative connotation to a lot of us. We think of chemicals as being evil, toxic, bad, ugly, things we want to stay away from. But in fact, chemicals are not just the toxic chemicals, the things that we do definitely want to stay away from, but they're also the chemicals that are good and the chemicals that are in everything. All of the stuff, all of the substances, all of the matter that we know about and are familiar with and are made of is chemistry. There's a little demonstration that I like to do that your teacher may do for you that involves some hydrogen peroxide and a little bit of beef liver. And when I go to classes to do this, I usually take some hydrogen peroxide and some Twinkies and an orange and some beef liver, and I hold them up and I ask the class, which of these things have chemicals in them? And of course, the thing that they answer first is the hydrogen peroxide. Well, that obviously has chemicals in them. I tell them that's pretty much just two fairly pure chemicals mixed together. This hydrogen peroxide from the grocery store or the pharmacy is only 3% hydrogen peroxide and 97% another chemical, water. And then I ask them, well, is there anything else here that has chemicals in it? And they'll quickly answer that the second one is the Twinkies. Now, of course, for a short period I wasn't able to use Twinkies because Hostess closed down, but the new Twinkies, whether they're as good as the old Twinkies or not, at least they exist, and so I can still use them. But anyway, Twinkies, of course, do have chemicals in them, including they have some chemicals that are added to increase the Twinkies' shelf life. They also have water that was in the hydrogen peroxide bottle. They have some other chemicals that you're probably familiar with, including sugar, a lot of it, and some fats and other chemicals. And then I ask if either of the other two things that I'm holding have chemicals in them. And sometimes, and this really depends on the class, I've given this presentation from second graders on up to high school seniors in AP biology, and you get a variety of responses, but eventually you can help the students to realize that the orange definitely has water and sugar. It actually has several different kinds of sugar that are all different chemicals. It has citric acid in it, it's a chemical, and a bunch of other chemicals. In fact, the orange has a lot more chemicals in it than the Twinkies do, and certainly a lot more than just the two chemicals that are in the hydrogen peroxide bottle. And then the most complex thing here out of these four that has the most chemicals is actually the liver, and it is nothing more than a collection of chemicals just like any of these other things are. All this stuff that you're familiar with, all the matter, is chemicals, and so biology is definitely composed of chemistry, and we need to understand chemistry to really understand biology. So chemistry is the study of chemicals that we just talked about, but also the reactions of chemicals. So what are reactions? Reactions are change. Reactions are one chemical changing into another. And we'll talk a little bit about that during this chapter and more later. And this is one of the reasons that chemistry is so vital to life, because the dynamic nature of life, the fact that it's changing, that really is life. Life is change. Here we have some living organisms, and here we have some very similar but not living, dead organisms. Now you can ask yourself, we also have some non-living thing like the pots or the cement or whatever. You can ask yourself, what's the difference between a non-living thing and a living thing? And there's some meaningful ideas that you could have about that. But what about the the difference between something that is dead and something that is living? And the answer is that the thing that's dead, there's no change. Now there's actually some change that you might note if you watch this over time, because it will degrade, but that is the life of decomposers acting on this non-living thing. Living things are full of change. Therefore, they're full of reactions. Okay? So understanding chemistry and the reactions are vital to understanding life.